Okay, question 9, last but not least, I suppose. Typically, again, the table that I gave you tells you all the differences between electrolytic and galvanic, as well as the similarities. But once again, they start with a definition. The term electrolysis, we are basically using electricity to force a chemical reaction to happen. So the chemical reaction is non-spontaneous, and we use electrical energy to make a chemical reaction happen. So there's 4 different options for the definition. The chemical process in which electrical energy is converted to chemical energy, or you can say the use of electrical energy to produce chemical change. And then, anyway, so definitions, you must study them, although you're probably not going to. But anyway, define the term electrolysis. We did that. Sorry. Then write down the reaction taking place at electrode Q. So electrode Q, it says an electrochemical cell is set up to purify a piece of copper that contains silver and zinc as impurities. A simplified diagram of the cell is shown below. Electrode R is impure copper. That means that electrode Q is pure copper. And the reaction that will be happening there is Cu2 plus 2 electrons is making Cu. So essentially what we're doing is we're making the Cu2 get oxidized out of the impure copper and then reducing it again onto the pure copper. So we are separating the Cu2 the copper, from the silver and the zinc. They said silver and zinc were impurities. Then they say in which direction do the electrons flow in the electrical circuit. So this is the anode and this is the cathode. Again, if you look on that table that I gave you, the flow of electrons is always anode to cathode. So in this case, it's going to be R to Q. Oh gosh, there, R to Q. It's always anode to cathode. So in this case, it's going to be R to Q. The impure metal in a purification system is the anode. The pure metal is the cathode. If you're doing electroplating, the pure metal is the anode. Again, all included on that table that I gave you. You can just study it if you don't have time to try and understand it. 9.4 is a stoichiometry question, basically. Calculate the current needed to form 16 grams of copper when the cell operates for 5 hours. So you need, this is a mass, work out molar mass. So copper is 63.5, sorry, not work out, get molar mass. So we have a mass, we have a molar mass, we can work out number of moles. So as with all stoichiometry stuff, you work out the number of moles. So we need to make 0.25 moles of copper, which is 16 grams of copper. And the number of atoms that is, we use this formula, which we probably last used in grade 10. It's 1.5 times 10 to the 23 atoms of copper. And so you need 2 electrons for every atom of copper, because it's Cu2 plus 2 electrons makes Cu. So every 2 electrons are needed for 1 atom of copper, according to the reaction that you're given on table 4b. So then you work out how many electrons you need. And once you have how many electrons you need, you can work out how much charge you need, because the charge of every electron is 1.6 times 10 to the minus 19. So you have the number of electrons, you have the charge of all the electrons, so you work out the total charge that you need. And 5 hours is 18,000 seconds. You get a mark for just working that out. So once again, if I can show you, everyone knows how to work out number of moles by now. We can get the A mark. If you work out 5 hours into seconds, because you know in physics, time is supposed to be in seconds, you can get another mark. You can get the A mark and you can get the D mark without doing the stuff in between. So you work out, they asked, what is the current that you need? Q equals I times T. You work out how many copper atoms, which means how many electrons, which means how much charge, which means how much current for 5 hours. It's 2.68 amps. Okay, so for the last question, it's actually very similar to that strength thing that we just did with the galvanic. And if I can just do it quickly, they say copper and zinc are oxidized. So copper is going to be the 0.341. It's going to be that one again. Zinc is this one up here somewhere. Oh, come on, brain. There's zinc. And then silver first. Sorry. Silver is down here somewhere. So here's silver. Okay, so now the question says, give a reason why silver is not oxidized. So all you need to say is like with the previous thing. You either argue on the left-hand side or you argue on the right-hand side. Because they're asking why silver is not oxidized though, they're asking about solid silver, I would suggest you do the right-hand side argument and you say that, so, it even tells you on this table that Ag is a weaker reducing agent than copper or zinc, and so it won't get oxidized. So let's just see what the memo says. So you see there, that first one, silver is a weaker reducing agent than copper or zinc and will not be oxidized. And all of that is written on the table as is. So you're comparing zinc, copper, and silver, and it tells you that these two are stronger because these two are higher up on the table because the arrow points to the top. So it tells you, the information is given to you on the table. So they either argue that Ag is weaker or that copper or zinc, or copper and zinc, are stronger. So therefore, silver does not get oxidized. So that's an easy-ish 2 marks if you just know how to use this table.